The number of squares added to the diagram each time is in the sequence 1, 3, 5. Therefore, 7 squares need to be added on the next occasion. We have 1 square, then we have 1, 2, 3, then we have 1, 2, 3, 4, 5. So 1, 3, 5, 7. The easiest way to add it is to add 7 squares to the base of diagram 3. So what we have there is actually diagram 3. We will add 7 squares to the base of diagram 3. We already have diagram 3. Add 7 squares to the base of it. 1, 2, 3, 4, 5, 6, 7. That's all there is to it. This results in diagram 4. What we have in the area column is a sequence of square numbers. So let us take a look at that. 1 squared, 2 squared, and 3 squared. So what we have in the area column is a sequence of square numbers. What do we imagine? The other numbers will follow the same trend, square numbers. So we have 4 squared, 5 squared, 15 squared. This is not rocket science. Whatever we have in the first column, the square of it will be in the second column. Any number, symbol, even a letter will be squared. So no doubt we will have n squared right there, and that completes the area column of the table. And we need to also complete the perimeter column of the table. Notice that what do we have? 1, 2, 3. We have 1, 2, 3 going up. As it pertains to the third column, the first number in each product is the exact same number in the first column. The other numbers will be according to the trend. So what we have here is what? 1, 2, 3. Then we have 1, 2, 3. So we will have 4, 5, 15. Right. And we'll have n also. Then what do we know? We are multiplying by 6 each time. Everything is multiplied by 6. Then what? We are subtracting 2. That's not difficult. Or subtract 2. And there we have the results of the calculation that we have here. 4 6 is 24, minus 2 is 22, 5 6 is 30, minus 2 is 28, and 15 multiplied by 6 is 90, and 90 minus 2 is 78. This one, do not know the value of n? 6n minus 2. The answers or values of all of the expressions will be our final step. 22, 28, 78, and 6n minus 2. There we have our velocity time graph, and we will have some fun in making the required calculations and arriving at the required conclusions. We need to determine the maximum speed first of all. The maximum speed is the speed associated with the highest point on the graph. So what is that speed? 12 meters per second. The highest point on the graph, 12 meters per second. What next? The number of seconds for which the speed was constant. A region of constant velocity is depicted by a horizontal line. constant velocity horizontal line. The 2 points mark the interval of time involved. So we begin at 6, we end at 10. 10 to 6, or 10 minus 6, is equal to 4 seconds. The area under the curve represents the distance traveled, and the area is in the shape of a trapezium, whose area of a trapezium, that is given by A is equal to B over 2 H1 plus H2. And the students are always bothered. They are worried. They have this burden on their heads. B is base, H1 is height, and H2 is height. It may have been A, B, C. It does not matter. Those two inside of the brackets are the parallel sides. And B that we have here, or whatever symbol that we are using here, has to be the perpendicular distance between the two parallel sides. It does not matter. H1 and H2 are the two parallel sides. May have been X and Y. It does not matter. The two parallel sides will be inside of those brackets, and B is the perpendicular distance between those two parallel sides. So B will go right there. The two parallel sides, we have 1, 2, 3, 4 units there, and if we count them, we have another 13 units there. But we do not need to count them because we have the mark right there. 13 units. The perpendicular distance, 12, represented by 12 meters per second. And that is why we have it right there. 13 plus 4 is 17, and 12 divided by 2 is 6. 102 meters. The region in which speed increase is depicted by a line of upward slope. So that is where we have speed increasing. The two pointers mark the interval of time involved. So time increased from 0 second to 6 seconds. The region in which speed is decreasing is a region of downward slope. The two pointers mark the interval of time involved. From 10 seconds to 13 seconds. And finally, the region in which acceleration is equal to 0 is where there is no change in speed. That is represented by a horizontal line. The two pointers mark the interval of time involved from 6 to 10 seconds. A farmer supplies his neighbors with pumpkins and melons. And we have some information that we will use in order to solve the problem. The total number of fruits must not exceed 12. Surely the sum may be as many as 12, but not more. This means less than or equal to 12. X plus y is less than or equal to 12. On the next slide, we will graph the inequality along with the other two that were given in this statement of the problem. So those are the other two. In graphing the line associated with the inequality x plus y is less than or equal to 12, remember that we need only 2 points in order to graph a straight line. when the equation of a straight line is defined with x and y on the left hand side, we equate each of them in turn to 0 and find the value of the other. X plus y is less than or equal to 12. This is a special form of the equation of a straight line in which the x and the y's are on the left hand side or just on one side, and a pure number is on the other side, in this particular case the right hand side. So we are using the fact that we only need 2 points in order to graph a straight line, and that fact we will use in graphing this one. For one of the points we will say x is equal to 0, and if x is equal to 0, what do we know? 0 plus y is equal to 12. Y is equal to 12. When y is equal to 0, what do we know? X plus 0 is equal to 12. X is equal to 12. The coordinates of the points through which a line passes are 0, 12 and 12, 0. The line associated with the inequality y is greater than or equal to 3 is a horizontal line that crosses the y-axis at 3. The line associated with y is less than or equal to x is the line y is equal to x that we know from equation of a straight line and straight line graph. We also know that line from transformation geometry. For all points on this line, the x and y ordinates are equal. It will therefore pass through 0, 0, 4, 4, 8, 8, 12, 12, and all of those points for which the x and y values are equal. Y is equal to x is the line on which all points have equal values of x and y. So let us put that in first. Notice that this is the point 4, 4, 4, 4. We go to 12. 12, 12. We go to 16. 16, 16. For x plus y is equal to 12, plot the points. We know the points already, that it will pass through 12, 0 and 0, 12. Draw the associated line. Y is equal to 3 is the horizontal line that meets the y-axis at 3. The region that satisfies all inequalities is usually the region bounded by all of them. Although we are sure that the inequality is x plus y is less than 12, it has to be below this line. Then we have y is less than or equal to x. It has to be below because it's less than this line. And the other one is y is greater than 3, so it has to be above this line. So the region is below this line, and above this line. So that is the associated region. To determine the smallest values of x and y that satisfy the conditions, take note of the vertices of the shaded region. Vertices of the shaded region. Those are the vertices. 3, 3. This one is 3, 3. Then this one is 6, 6. And this one is 9, 3. The vertex has to be 3, 3. That is the vertex for which we have the smallest value will have to be 3, 3 because both of its ordinates are less than or equal to the ordinates of the others. So here we have 3, 3. 3 is less than 9, but 3 is equal to 3. Because 3 is already less than 9, we are sure that this will give a smaller value than this. No problem seeing this one. 3 is less than 3, and 3 is less than 6. So that one will give the smallest value. Remember that the minimum or maximum values that satisfy the conditions must be at one of the vertices of the region. So whether we are talking about maximum or minimum, the maximum or minimum will be located at one of the vertices of the shaded region. Circle theorem, and we have this lovely diagram. What do we need to find first? We need to find P, T, R. P, T, R. To find the angle PTR, we need to make use of the fact that the angle PTR, which is this one, PTR, at the circumference that is subtended by a chord. That is our chord. The angle is subtended by the chord at the circumference. Of course, PT is at the circumference subtended by the chord. PR is equal to the angle QPR that the chord makes with the tangent. So the angle that the chord makes with the tangent, which is this one, is equal to the angle that is subtended by the chord at the circumference. So that angle is also 46 degrees. To find TPR, we will consider that the sum of the angles of any triangle is equal to 180 degrees. So there we have our triangle, and the sum of the angles in a triangle is equal to 180 degrees. We have this one, we have this one. We have a part of the other one. All we need to do is find this one, which is going to be the difference between the sum of these and 180 degrees. So TPR plus 46 plus 46 plus 32, if we add all of these, the result is 180 degrees. Therefore, TPR is equal to 180 degrees minus 124 degrees. That is equal to 56 degrees. Do we have it there? Right, that's the angle that we were searching for. Finally, for TSR, opposite angles of a cyclic quadrilateral are supplementary. They add to give 180 degrees. So TSR plus 56 is equal to 180 degrees. This is our cyclic quadrilateral, a four-sided figure with all vertices in contact with the circumference of the same circle. Opposite angles of a cyclic quad are supplementary. They add to give 180 degrees. TSR is 180 minus 56, which is equal to 124 degrees. For part B, we have a diagram that is actually a two-dimensional representation of a three-dimensional setup. Let us place EF is equal to 8 meters and FG is equal to 6 meters, and the diagrams, those were given in the statement of the problem. Our first duty is to find FT. FT. FT or TF is opposite to the known angle, and the known side is adjacent to the known angle. We are at opposite and adjacent. So let us apply the tangent trig ratio. Do not forget that TF is a vertical pole, and that this triangle that we have right here is drawn on horizontal ground. Therefore, TF is perpendicular to the ground. The triangle is drawn on the ground. Therefore, TF is perpendicular to EF and is also perpendicular to FG. So TF is perpendicular to FG. Do not forget that this is a two-dimensional representation of a three-dimensional setup, and we are sure that any line that is drawn on the horizontal ground has to be perpendicular to the vertical pole. Therefore, we have a right-angled triangle right here. As we said before, TF is opposite to the angle that we have right here, and FG is adjacent to the 55 degrees. Therefore, we have opposite and adjacent. The tangent trig ratio is applicable. So TF over 6 is equal to tan 55. No problem seeing that TF is equal to 6 tan 55. That turns out to be 8.57 meters. There we have the triangle that is on horizontal ground, and we need to find EG, this one. Clearly, this angle is not a right angle. As a matter of fact, it is stated to be 120 degrees. 120 degrees is not a right angle. A right angle is 90 degrees. We will make use of the cosine rule that pertains to two sides of a triangle and the angle that they form. So we have this 120 degrees angle. We have the two sides that form the angle. So two sides forming the 120 degrees angle. And we will use the cosine rule. The cosine rule is used, or this version that we'll be using is used when we have two sides of a triangle and the angle that the two sides form. It is used to find the side that is opposite to the known angle. So EG squared is equal to this side square plus this side square minus 2 times this side times this side times cosine of the angle that the two sides form. And that is what we have represented right there. In simplification, do not forget that the cosine of an obtuse angle is negative. So when we work this out, we will have negative 96 multiplied by negative 0.5. That turns out to be a positive 48. When we add them, we get 148. We imagine that the length of that side, which is the square root of 144, will be very close to 12 meters. Finally, EFT is also right angled for a reason that we have discussed already, and TF was calculated to be 8.57 meters. Let us see if we have that inside the diagram. Right. So we have TF to be 8.5 meters, and of course the other one is given. We know that this is perpendicular to this line because this line is drawn on horizontal ground and the pole is vertical. Horizontal and the vertical are right angles to each other. And what do we need this bit of information in order to determine? We need to determine the angle of elevation of the pole from E. The angle of elevation of TF from E is the angle at E. TF is equal to 6 centimeters, and that is adjacent to it. So TF is 6 centimeters and is adjacent to the angle of elevation at E that we are attempting to find. So this one adjacent to this angle. The other side that we have is opposite to the angle. The tangent trig ratio may therefore be used. So tangent of the angle E is equal to opposite over adjacent, and that turns out to be 8.57 divided by 8, opposite over adjacent, and that is equal to 1.071. In order to find the angle, we need to find a tan inverse of 1.071. If we have the angle already and we need to find the tangent, that is simple. Just say tan of the angle, and that is not difficult using our calculator. But in this particular case, we have the tangent of the angle and we need to determine the angle. Not so difficult either. We need to find what we call the inverse or the reverse of the tangent, which is tan inverse. So tan inverse of 1.071 we imagine is close to 45, because we know that tangent of 45 degrees is 1. So we are sure that that angle is close to 45, no doubt. E is equal to 47 degrees. Our first duty is to find the matrix product A, B. How do we imagine that we will do that? Of course, multiplying as we always do row by column. There we have a representation of your product, which is we take row multiplied by column. Row multiplied by column. To the extent that we have the upper multiplied by the left, and the answer goes to the upper left. So 1, 5, 2, negative 2. 1, 5, 2, negative 2. Then we have the upper with the right, and the answer goes to the upper right. That is, we have 1 multiplied by negative 2, 2, 1. 1, negative 2, 2, 1. Then we have the lower multiplied by the left. The answer goes to the lower left. This is not rocket science. Lower left. The answer goes to the lower left. So we have 2, 5, 5, negative 2. 2, 5, 5, negative 2. Then we have 2, negative 2, 5, 1. The lower with the right, and the answer goes to the lower right. I have a special liking for this particular problem because by solving this problem, the examiners are expecting us to make use of our knowledge of the special attributes of matrix multiplication. We are multiplying two matrices and the result is 1, 0, 0, 1. This matrix, we should know, is the multiplicative identity for 2 by 2 matrices. And if two matrices multiply to give this one, then we are sure that one is the inverse of the other. Therefore, we are sure that A and B are inverses of each other, and that we will make use of in solving the problem further. We need to find B inverse. Because of this, because when we multiply A by B, we get the identity matrix for 2 by 2 matrices, the multiplication of 2 by 2 matrices. We are sure that when we work B inverse, we will get the matrix A. Therefore, we will find B inverse, which is 1 over the determinant, 1 over 5 times 1 minus 2 times negative 2. So 1 over 5, 1 minus negative 2, negative 2. That is 1 divided by the determinant, or the reciprocal of the determinant. Then we will finish up by exchanging the places of these two and changing the signs of these two. When we are through, we realize that we will have 1 divided by 1, and that turns out to be anything divided by 1 is 1, and then 1 multiplied by anything is that same thing. We'll end up with B inverse is equal to 1, 2, 2, 5, which is A. So by multiplying A and B, we realize that we get the identity matrix, which is usually the result of multiplying a matrix by its inverse. Therefore, we are sure that A and B are inverses of each other. Therefore, when we are asked to find B inverse, what we expect for B inverse is A. So the answer for B inverse has to be A, since they are inverses of each other, determined by the fact that this product turns out to be the multiplicative identity for 2 by 2 matrices. So B inverse is equal to 1, 2, 2, 5, exactly the same matrix as A, as expected. Now we have a particular product. We are given that 5, negative 2, negative 2, 1 multiplied by xy is equal to this, and we are required therefore to find the values of x and y. The first matrix on the left is B, as we can see. In finding the values of x and y, we need to multiply by the inverse of that matrix on the right hand side. Therefore, we will find x and y by eliminating this matrix from the left hand side. By so doing, we will have the inverse of this matrix being multiplied by 2, 3 on the right hand side, and we know the inverse of that matrix already. The product of A and B gives the identity matrix. Therefore, A and B are inverses of each other. We multiply the right hand side by the matrix A. So we are required to multiply the right side by the inverse of the matrix B. We are sure that the inverse of the matrix B is the matrix A. We go straight ahead and multiply by the matrix A, and that will be done in a matter of seconds, because we already know the relationship between the matrix A and the matrix B, already established. When we determine the product row by column, so 1, 2, 2, 3, 1, 2, 2, 3, then 2253. The answer turns out to be that x is equal to 8 and y is equal to 19. Vectors. Let us put the information or the remaining information inside of that diagram in order that we may go straight ahead and finish solving the problem. M and N are points on J and K. M and N are points on JK and JL in such a way that JM is equal to 1/3 JK and JN is equal to 1/3 JL. Let us insert those points in the diagram. M and N. Jm is equal to U and Jn is equal to V. Do not forget that this is 1/3 of the entire distance and this is 1/3 of the entire distance. Jm is 1/3 of Jk. This means that Jk is 3 times Jm. Jm is equal to U. This implies that Jk is equal to 3U. Jk is equal to 3U. Jk is the first one that we needed to determine. Let us take a look at the movement required to go from M to N. From M to N. M to N. We go negative U plus V. We are going in the opposite direction to U, that is negative U, and then plus V. Or we may just write V minus U. Mn is equal to V minus U. Finally, let us take a look at the movement required to go from M to N. All the way like that. Good. There's no difficulty seeing that. Opposite direction to U, minus U, and positive V. So we have 3 of them. Negative 3U plus 3V, because we are going in the opposite direction to the vector U. So negative 3U plus 3V. We may write the positive first. 3U minus 3V. In this final part of the problem, we need to use the vectors that we have found so far, deducing the geometric relationship between the two of them. So we have Mn is U minus V and KL is 3V minus 3U. On inspection, it is obvious that KL is 3 times Mn. If a vector can be expressed as a real number multiplied by the other, then they are parallel. It follows that KL is equal to 3 times Mn and the vectors are parallel. No doubt, one is 3 times the other. If that is obvious, or we can come to that conclusion, or we can show that one is 3 times the other, then we are sure that they are parallel. So the two relationships are, they are parallel and one is 3 times the other.